All right, what we got here is section 9.3, the final section we're going to do this year. And 9.3 is trigonometric functions of any angle. So what we've been focused on so far are right angles, but now we're going to see, okay, how do we deal with it if they're not right angles? Well, not only that, there has to be a right angle somewhere, but all we've really learned about is how to deal with just the right angle. So we're going to, which isn't necessarily true there. Anyway, we're going to continue on. And so we need to graph this point. It's a point on the terminal side of an angle theta. I don't know why there's an X there, theta, in standard position. So if we have our graph here, the point 8, negative 6 is 1, 2, 3, 4, 5, 6, 7, 8. The negative 1, 2, 3, 4, 5, 6. It's about right there. So this is 8, negative 6, and I am just going to write those numbers there. I know that this is a right angle, and so this point is what this terminal side is here. Okay, and so I just created a triangle with that terminal side, basically. And we want to find the 6 trig functions. So we've got the sine of theta, the cosine of theta, and the tangent of theta. Then we have the cosecant of theta, the secant of theta, and the cotangent of theta. So the first thing we should probably do is find the hypotenuse here. And so we're going to use the Pythagorean theorem for that. 8 squared is 64. 6 squared is 36. So we have 100. The square root of 100 is 10. And so the length of this hypotenuse is 10. So now we're going to find the sine. And we're talking about this angle right here. Okay? And so the sine is the opposite over the hypotenuse, so that's 6 over 10. And we do need to reduce, divide both by 2, and that's 3 over 5. The cosine, oh wait, but the problem here is, sorry, this was a negative 6, negative 6. So that means that this has to be a negative 3. Make sure you follow those signs. Okay, that's important. The cosine is the adjacent over the hypotenuse. So we've got 8 over 10, and if we reduce, divide both by 2, that is 4 over 5. And the tangent is the opposite over the adjacent, so negative 6 over 8, that is negative 3 over 4. And what's nice is once you have those 3 done, then you can just flip them to find the others. So the cosecant is the opposite of the sine, so 5 over negative 3. The secant is the opposite of the cosine, so 5 over 4. And the cotangent is the reciprocal of the tangent, so 5 over negative 3. Okay. Number 2, it says use the unit circle, which we put together in class, to evaluate the 6 trig functions of theta equals 90 degrees. So if we were to graph that, 90 degrees would be right here. Okay, and on the unit circle, that means our radius was 1. So this would be the point on a coordinate plane 0, 1. Okay, and we're going to use the unit circle to evaluate the 6 trig functions of that. And so we've got the sine of theta, we've got the cosine of theta, and the tangent of theta. We've got the cosecant of theta, the secant of theta, and then the cotangent of theta. So the sine, if you remember, we talked about this more in depth in class, but the sine is when you find the y value and divide it by the radius. So the y value here is 1. The radius, of course, of our circle is 1, and 1 over 1 is just plain 1. Okay? The cosine is your x value divided by your radius, and your x value is 0. Your radius is 1, and so the cosine of 90 degrees is 0. And if you were to type that into your calculator, you would get the same exact thing. Okay. The tangent is going to be y over x, and so the y value is 1, the x value is 0, and anytime you divide by 0, the world blows up. And so we say that this is undefined because you divide by 0. And it's okay to have that in a trig function, by the way. The cosecant is just the opposite of the sine, so 1 over 1 is still just 1. The secant is the reciprocal of the cosine, so if you take 0 divided by 1 and flip it, it's 1 divided by 0, and we just talked about how that turns out to be undefined, and that's okay. There's nothing wrong with that. And then the cotangent is just the opposite of the tangent. So if we flip-flop it, we get 0 over 1, and this time we get 0. So just because the tangent is undefined, it does not mean the cotangent will be undefined. And that's a really nice pattern that you should start to see when you do your homework. So that's helpful. Okay. Number 3, find a reference angle theta prime for each angle. Okay, so a reference angle, remember, is just the angle that your terminal side creates with the x-axis. So if I were to graph negative 220 degrees, well, if I start here, negative means we're going clockwise. So if I go here, that's 180 degrees. Okay, and so if we have 180 degrees and we need to get to 220, 220 minus 180 means we need to go 40 degrees more. So this angle right here would be 40 degrees, and that is your reference angle. A lot of the times, in order to draw your angle, you have to find the reference angle anyway. The reference angle for this is a 40-degree angle. Okay. If you've got 15 pi over 16, the way that I look at this is I'm like, okay, well, if we had 16 pi over 16, that would be just pi, right? And so we're very, very close to pi over 16. We're not quite there yet. But in order to get to 16 pi over 16, because if you remember, pi is over here. If we're going this way in the positive direction, pi is over this way. So we're not quite there yet. We still have a little bit of ways to go, and I'm like, okay, well, how much more do we have to go? Well, to get from 15 pi over 16 to 16 pi over 16, we just need one more pi over 16 to go, and that's right here in order to get to that x-axis. And so your reference angle is then pi over 16. Okay, don't think too hard on these. These are really easy to overthink. Don't do it. Okay. Number 4, evaluate the negative cotangent of negative 210 degrees. The first thing I want to do is draw my angle. So if this is my axis, negative 210, that means we went this way, we went 180, and then we went 30 more. So this is 30 degrees. Okay, so 180 plus 30, that would give you 210. So here's our imaginary triangle that we drew. It's right here. And this is a special right triangle. That means that this side right here is the square root of 3. This is 1 and this is 2. Okay, you should have that memorized. Hopefully by now, maybe not. So the negative cotangent, that's the same thing as saying, okay, well, that's negative 1 over the tangent, right? And the reference angle that we're going to be using is 30 degrees because that's the degree to create our triangle. So really what we're finding is 1 over the tangent of 30 degrees. Okay? And that's the same thing. Well, the tangent of 30 is the opposite over the adjacent. So the opposite over the adjacent, so 1 over the square root of 3, and you're like, oh my gosh, there's radicals, there's fractions. Yes, there are, but when you're dividing by a fraction, it's like multiplying by the reciprocal. So really, we've got 1 times the square root of 3 over 1, and that just simplifies to be the negative square root of 3. So it actually worked out kind of nicely, okay? Don't rationalize the denominator until the very end, unless you absolutely have to, okay? All right, last one here. Estimate the horizontal distance traveled by a golf ball that is hit at an angle of 40 degrees with an initial speed of 90 feet per second. So I gave you this in class. The distance something travels is the velocity squared over 32 times the sine of 2 theta. Okay? And so the velocity that they said we had was 90 squared over 32 times the sine of 2 times the angle, which is 40 degrees. And you can plug that straight into your calculator just like you see it. Don't even try to do anything else, and you should get about 249.28 feet. That's how far the golf ball travels. Okay. Hopefully that helped. Remember to review your unit circle. Yeah, let me know if you have questions, and congratulations, we finished. Yay!